Well, here we are, our last chapter, and it's our first exposure to calculus. So we want to talk about that first. We will go into calculus in the uh, next part of business eco. But this is our first concept of understanding what calculus measures. So we're going to start first with something called limits. What is the most I can do, right? Is the limit of how much I can do in one day. That's my limit of working no more than 8 hours a day. By that time, my brain is mush. Well, in calculus, we measure what are the extremities of the function that we're working with, or what is the limit at one specific position of x within that function. And that's what limits are. So this is what I got from your textbook. Let f be a function. That means for every x there is only one y. And let a and l be real numbers. If, as x takes a value closer and closer, but not equal to a on both sides of a, the corresponding value of f of x is the limit, L. So, okay, so what we're saying right there is that we're taking the limit as the independent variable x approaches some constant from both sides. And we'll be looking at this. This means that we have to take the limit as x approaches a from the left and the limit as x approaches a from the right. And these two values must be very, very close to each other to have this occur. It doesn't have to exist at the point, but it has to get very, very, very close to that point. The value of f of x can be made as close to L as desired to take values of x closest to A. So, as we approach this function, the limit as x approaches A is a value. All right. Now, let's discuss that a little bit. Now, we said in this case that let me get this, make sure that you understand, because it's all basic on this. So if I have a function and I'm drawing it, and I have a line coming over here, and it is coming this way is a value, then it starts off over here. Sorry about that. It starts here and goes this way. Well, it is a function. For every x, there is only one y. But here it's approaching a number from the left, and here is the right, and there's a gap. Therefore, does not exist. That means that the limit of x approaching some a for this function does not exist. There's a gap. If there is a gap, then it can be a hole, but not a gap. So let's draw one that is. All right. And it does have a gap. an open hole. So supposing I have this. All right. So as I approach this from the left, it approaches this number. If I approach from the right, it's approaching the same problem, the same one. So the limit does exist. So it's a hole, it can't. Well, then we have another condition about that. There's three ways of looking at this stuff. So supposing I have this, and I want the limit at this A. Well, it does exist. The limit at, of x approaches A is that value. There is no break in the line. This is a continuous function. So if it is continuous, then a limit exists anywhere on it. Right, so this is our basis. So let's look at this. If the limit f of x from the left is 3, limit f of x equals 4 from the right, then the limit, what? Does not exist. Okay, so if we have it, let's try to draw this. So if we're coming from the right, it goes to 3. Approaches 3. And then if it comes from the left, it approaches 4. So there's still a gap. So this does not exist. All right. So now we're going to look at a graph. Oh, we've got a parabola and we have what's known as a removable point. Oh, well, a function, it just doesn't exist right here. So it says, as we approach 7, so here is 7. Okay, if we approach 7, right? Let me look. 1, 2, 3, 4, 5, 6, 7. Yes. What is the limit as f approaches cap f? So that would be 1. What is it when we approach a? 1, 2, 3, 4, 5, 6. So in both cases, the limit exists. Right. So there we have it. So, um, did I count wrong? 8, 1, 2, 3, 4, 5, 6. Yeah. So we have a limit. Even though f of 7 does not exist, we have a limit. So that lets you know how to do this. Here we go. Now we're going to do the steps. In this problem, it says use the graph. We got a graph down here to find the following limits and function values of each of A. The let's see, I is from the left, double I is from the right, and f of x is the value and if it exists. All right. For A equals 2. For A equals 2. So we want the limit as x approaches 2 from the left for f of x. All right, so from the left, it approaches the limit as x approaches a, 2 rather, from the right. So as it approaches 2 from the right, it's negative 2. Now, we want f, the limit, now we assess the limit as x approaches 2 of f of x does not exist because of the gaps, and we know that f of 2 equals negative 1. So none of these match. No match, no match, no match. Okay, now we do b. We want the limit as x approaches 4 from the left. Approaches 4 from the left. Okay, so as it approaches 4, it gets to negative 1. The limit as f of x as x approaches 4 from the right is also 1. We're going to do f of 4 is negative 1. All three equal. Therefore, we can say the limit approaches 4 for that function is negative 1. Because it's continuous during that segment of that graph. All right. So here we have a graph. Refer to it as the limit as x approaches infinity. Well, right here we have y equals 2.25. It is a horizontal asymptote. And we studied these earlier in our chapter 10. And an asymptote means that the line will never cross it, but it approaches it. So in this case, as we go to infinity, I get closer and closer to this value. So we can say that the limit as x approaches infinity for this function to 5. Right. Now we have a table. Reading tables is the most fun. Okay, that means the function is continuous, and as we get closer and closer to where we think our value is. All right, so look at this. As we approach 2, now remember, 2 is right here, right? So as we approach 2 from the left, approach 5. Limit as x approaches 2 from the right, we also get 2. Now, do we know the value? No, but we know, I'm sorry, 5. But we know these two match. Therefore, the limit as of this function is 5. All right. one's interesting because it states f of x and g of x as the numerator and denominator. And what they've done is they've taken the limit for each of the components. And that's possible. And it opens up the window to how we look at these functions. So the limit as f of x approaches 4 is 7 for f of x. And the limit as g of x approaches 4 is 35. So our limit is 1/5. Just as easy as that. All right. So let's look now at some rules of limits. This is important in figuring out more about limits. All right. We haven't done any real calculus, but this is calculus. All right. We know that the limit as x approaches a of a function is cap a. And the limit of g of x approaching a is cap b, so some value. So we know these two things exist. If k is a constant, then the limit of k as it approaches a will always be k. All right, now what does that mean? All right, let's talk about that before we go any further. So if y equals 3, have a horizontal line. So the limit is whatever that is. So it's going to be k, 3. And that's what it's saying. So if k is a constant, then the limit of the function that has a k is k times a for f of x and k times cap b for the g of x. So now let's talk about the sum and difference. That means that we can individually do each component. We can take the limit of f and then the limit of g and get the total limit of their sums. The product is very interesting because it takes, we can take the limit of f times the limit of g and then multiply their product. Of course, in the next one, we'll be talking differently about those things, but that's what we have. Now, this one we did in an example. We take the individual so long b does not equal 0, because we can't divide by 0, it's undefined, then we can have a limit. All right. So we're going to use the properties of limit to decipher if a limit exists. If a limit does not exist, find the value. Value. All right. So in this case, we have to do, so we're going to say the limit, because we know if we drop in 8, we're dividing by 0, and it does not exist. But we can't say that because we're taking it from the left and the right. All right. So this means the limit as x approaches 8, or x squared minus the 64, over the limit as x approaches 8 of x minus 8. Well, this is that 0 thing, right? And this equals to some value because it's 0 over 0. Well, what we're going to do is factor x plus 8 and x minus 8 equal that. And then we're going to do x minus 8. And what happens here is we can cancel that. And now we can take the limit. Therefore, the limit as x approaches 8, or x plus 8, is 16. Cool, isn't it? Okay, so now we do this one. In this case, it's infinity. So what we want to do is state that we're going to have infinity over infinity. Well, that's kind of silly. So we're going to take the limit as x approaches infinity, sorry, not 8, and we're going to divide by x. 8x divided by x over 6x divided by x minus 3 divided by x. Now, the reason we do that, because infinity we can never manage. And what we're talking about is a horizontal asymptote. So that would give me 8 over 6 minus 3 over infinity. Well, this is 0 because it's so small. So my limit as x approaches infinity is my horizontal asymptote is 8 over 6, and we're going to reduce that to 4/3. The limit is 4/3. It's a horizontal asymptote. Again, we could see it right here because the degree of the numerator uh, and again, we studied this before, is the same as the degree of denominator when we did rational expressions. But in calculus, we just divide everything by x to get it to where it is. Now, this is piecewise, and it's a different animal because we don't know if there's gaps or not. So we're going to look at A. They want 5. Well, 5 here and 5 here are what we need to look at. So if I put in 5 minus 3, I get 2. That's the limit as x approaches 5 from the left. It doesn't get to 2, but uh, um, it's 2. All right, so now we're going to do the next one. The next one is 2. The limit as x approaches 5 from the right is 2. Therefore, the limit as x approaches 5 of f of x is in fact 2. All right, now we're doing 6. Now 6 are these two. So we know f of 6 equals for sure. And now we're going to do the limit from the right. Limit as x approaches 6 from the right is going to be 6 plus 3 equals 9. Well, these not match. Therefore, the limit as x approaches 6 of f of x does not exist. It's as easy as that. All right. Well, this guy right here, again, is a, sorry about that. This guy right here is a portion of developing a table to verify your graph with your graphing calculator. All right, now we know that we can factor this. X plus 1, x minus 1 over x plus 1. We know we have a removable dot because these do that. And it's -1, so it's going to be a -2. But we want to see this completion. All right, so we're going to enter this in our calculator. Here we go. Go to the y equals, clear out anything we have in there, and we're going to put parenthesis x squared minus 1 divided by open parenthesis x plus 1. All right, x plus 1. Mistake there, didn't I? And we're going to go zoom 6 because I don't know what I've done with the calculator. And it looks like a straight line. Okay, so they want us to find negative 1.1. So we go second calc value, negative 1 point, negative 2.1. Now we're going to do negative 1.01 and enter, and we're going to get a negative 2.01. Now we're going to do a negative 1.01. We're getting closer and closer to that 1 without negative 1, without getting to that 1 because we know it doesn't exist. And we're going to hit enter, and I get negative 2.001. Well, let's just do negative 1, right? So we're going to do a negative 1. I get nothing because it's an open hole. Now that proves it. So now we're going to do negative 0.999, and we're going to get 0.999. Oops, can't read that, can you? And then we're going to do negative 0.99. All right, and we're going to enter, and I get 99. And then I'm going to get the furthest away from negative 1, negative 0.9, and that gives me a negative 1.9. Well, if we wanted it for negative 1, we want the limit, because that's what it asks for. Then we know it's between these 2 points, and of course it's 2. So the limit as x approaches negative 1 for this function is negative 2. There you have it, guys. Pretty awesome, right? Okay, we've done tables, we've done graphing, and now we're doing some general. It says, so I have this function. Now we know that the degree is 5 on the bottom and 1 on the bottom. So we have a horizontal at y equals 0. Never cross that line. We want negative 4. Find the limit. Okay, so for A, we want the limit as x approaches negative 4 of cap f of x. All right, so I'm going to go, I'm going to put it in because it exists, right? So I'm going to have 6 times divided by 6 plus 4 to the 5th. All right, that's a negative 24 divided by 10 to the 5th. So that's a negative 24 over 1, 2, 3, 4, 5, 100,000. All right. So find the vertical asymptote. Ah, okay. So we know that it exists at negative 4, somewhere in this vicinity. Or do we? I don't know. I'm thinking we do because it's a horizontal asymptote. Might be infinities. What about that? Okay, so, oh, it said negative 4, and I put 6. Oh, I made a mistake. Sorry about that. Sorry. It does not exist, does it? We're going to have to do, I apologize. Let me do it again. I wrote 2 things down at once. We want to find limit x approaches negative 4 of f of x. Now, what happens here is we've got 0 in the denominator. We have 6 times that negative 4 over 0 to the 5th. And this does not exist. So we have an asymptote, right? Now, we want to check to see what it looks like. So we're going to go to y equals, and we want to know if it goes to negative infinity or positive infinity or whatever, or 0. All right, and I'm thinking it goes to 0 because y is the horizontal. Okay, So we want to enter 6x divided by, open parenthesis, x plus 4, close C, up caret 5. All right. And I think this graph is too big. Nope, look. On one side, it goes toward positive infinity. The other one, it goes to 0 at 4. Yes. Okay, so this one does not exist. Because the limit x approaches -4 for cap f of x from the left is the limit as f of x as x approaches -4 from the right, negative infinity, so does not exist. All right, now what we have is asymptote. Sorry about that. Fast, didn't I? And that's because I wrote the wrong things. Want vertical. So that means x equals 4, -4. And that says, compare your answers to part A and B. What can you conclude? Okay, that we have to graph. Fully understand. That asymptotes affect a limit. All right, yeah, that takes care of that one. So now here's our last problem, or next to our last problem, I think. The cost in dollars of manufacturing a particular flash drive is this. All right, so we have C of X equals 17,000 plus 4X, where X is the number of flash drives produced. Recall from the previous chapter that the average per flash drive, denoted by C bar of X, is found by dividing by X. Okay, so they want us to now construct C bar X. Oh, no problem. So we're going to have 17,000 divided by X plus, right. So what does this tell us? All right, that the average cost as it goes to infinity. All right. All right. So if it goes to infinity, I have 17,000 divided by infinity plus 4. So it is 4. The average cost of the flash drives is $4. $4. So the more you make, the closer you get to making the price $4 per flash drive. So if you only do one, well, it's costing you a fortune just to run the machines. And that's what that means. All right. Now do your homework. Thank you for listening.